Okay, hello everybody. So today we'll be talking about AC circuits. You all have studied that electric current is basically the flow of charges, right? So, if electric current is the flow of charges, we have two kind of currents that are flowing. They are generated by different sources, but if I have to talk about, if I have to classify electric current based on direction of flow, then I have two type of currents. One is DC and another is AC. What does DC means? It means direct current, and this means alternating current. Now, what does direct current mean? Direct current means that as the time is changing, the current doesn't change the direction. Yes. So one of the possibility is that the amount of current that is entering is in the same direction and it's continuously of the same amount. Yes. So this is a constant direct current. The, the current which has same direction plus constant magnitude. But another case for the case of direct current only can be this one, when the current has only one direction but its magnitude is changing. For example, this is how the current keeps on increasing its value, making it to zero after time, but let's say it's 5 ampere. So current is increasing its value from 0 to 5 ampere and then again to 0 in t time, let's say. So this type of direct current has same direction but varying magnitude बदल रहा है. This is again called as pulsating DC. The current which comes in pulses increases to its fixed value, then reduces to zero value but doesn't change the direction. So this is the case of direct current. But the current which you are going to talk about right now is alternating current. Okay, so what is alternating current? The current which is going to change its direction. So if I have to draw it, you will see that this is the current which will first increase its value to a certain extent, then make it zero again, and then start moving in the opposite direction, and this is how the cycle will continue. Let's say this is a time period in which one complete cycle is completed. One complete cycle of current variation is visible. Let's say this is 5 ampere plus 5 ampere. So current basically in time t by 4 increases to its maximum value in the positive direction. Then in time t by 2 it becomes 0, and then again in time 3t by 4 it reaches to its maximum value but in the opposite direction, and then at t again it becomes 0. If you actually go and see a circuit which has DC current, which has AC current flowing, you will find that the current flows in this way, that if you have a resistor connected here, then for the first cycle the current will move from here to here, and then for the second part of the cycle it will move B to A. It is denoted by this symbol. As of now, you were showing this type of constant current using batteries, symbol like this, but this is a kind of this is AC source, right? This is your AC source. Now the thing is, what produces DC? So DC can be produced by device. DC can be produced by your batteries, chemical batteries, you can say. Then they can also further be produced by DC motor also. DC motor is what generates this type of current. DC मोटर इस टाइप का करंट जनरेट करती है, और इस DC मोटर पे अगर आप प्लस एक कैपेसिटर लगा देंगे सर्किट पे, तो दैट वुड गिव यू अ काइंड ऑफ दिस टाइप ऑफ करंट, कांस्टेंट वैल्यू. वाई? बिकॉज कैपेसिटर क्या करता है, जब वैल्यूज़ रिड्यूस करने लगती है करंट की, तो कैपेसिटर डिस्चार्ज होने लगता है, एंड इट ट्राइज टू मेक दिस पल्सेटिंग साइड, it tries to charge it in a way that this value seems to be a constant, like this. So this is a direct current is produced by DC motor plus capacitor arrangement, and then I said chemical batteries about chemical batteries also. Now if I talk about AC, so AC is produced by generator. You have AC generator, and AC generator has specifically one thing which we call slip rings. These slip rings are the ones which enable the generator behave like a alternator, like something which can change the direction of the current. So if I have my coil like this, I would have two rings in this coil. I would have two rings in this coil connected this way, and we can see one carbon brush here, another carbon brush here, and this is how my load is connected here. This is a bulb. So आप क्या करेंगे, जब आप इसमें देखेंगे साइकिल को, for the first part of the cycle the current will move in such a way, like आप ये कह सकते हैं कि this it's going B2A. Yes, and when you'll see, you turn it, these are the pole, north pole and south pole. This we can do in other video. If you want to talk about alternating generators, then we'll talk about that. But in the first cycle the current will move from B to A, and then in the second cycle, like when it will flip this way, it would start moving from A to B. So this is how the alternating circuits work. Now once this is done, once we know the basics about alternating current, it's time to know how do we represent alternating current. So you saw that alternating current is shown like a sinusoidal wave, and you know that physics is basically interpreting the nature behind around us, and then writing some mathematical expressions for them, because mathematics is the language of physics. So if you see something like a sinusoidal wave, then you have to find out a corresponding mathematical function which can explain this. Yes, so we would find that the current can be written as I is equal to I naught sine omega t plus phi. It's a sine. I naught is the maximum value of current. And sine omega t is that function which will tell me that at different times sine will have different value, and this would give me different value of current. So you can see ये जो आपका 5 एम्पियर है, ये बेसिकली आपका आई नॉट है, मैक्सिमम वैल्यू है करंट की. तो आप देख सकते हैं कि जैसे जैसे टाइम बदल रहा है, आई की वैल्यू अलग अलग आएगी. यहाँ पे टाइम T1 है, टाइम T2 पर अलग आएगी, T3 पर अलग आएगी, and this is happening based on this sine curve. Yes, so this is one case. Now the other case is what is this omega? So omega is angular frequency of current. Basically, frequency means how much is the current changing, variating, or you can say vibrating about its position, or I can say about the points about the circuit for which I'm writing the values. So if I have to say the angular frequency of the current, see, you all have studied SHM in class 11th. So आपने देखा था कि उस समय हमने इस फेज को यूनिफॉर्म सर्कुलर मोशन से रिलेट किया था। यस, हमने देखा था कि एक वेक्टर था, फॉर एग्जांपल अगर मैं इसे आई नॉट कहती हूँ तो आई नॉट का एक कंपोनेंट ये होगा आई नॉट, लेट्स से आई कॉल दिस एज थीटा, तो दिस वुड बी आई नॉट कॉस थीटा. Similarly, upper component will be I naught sin theta. And I know that as this vector keeps on moving across this around this circle, the value of this x component is going to change. मतलब अगर ये वेक्टर I naught इधर की तरफ आ जाए तो इस component की value again क्या आएगी? This one. And then further, if this vector goes here, the value would change like this. So you know that this x component of the current keeps varying like a sinusoidal, or like a sinusoidal function, or you can say the cosine function also. So theta is basically how is the current changing the direction. So I had written theta is equal to omega t as a kid, and I know that in a circle, as a kid means in class 11th. सो थीटा इज़ इक्वल टू 2 पाई फॉर वन कंप्लीट साइकिल, यानी ये पूरी एक साइकिल होने में जो थीटा कवर होता है दैट इज़ 2 पाई. एंड ओमेगा इज़ योर एंगुलर फ्रीक्वेंसी, हाउ मच इज़ द डायरेक्शन चेंजिंग इन वन साइकिल, एंड देन टाइम टेकन इज़ टाइम पीरियड. सो ओमेगा विल बी 2 पाई अपॉन कैपिटल T. So this is our angular frequency, and this you can use and put up in the values and you get the varying answers. I'll be back just a second.